Hi guys, welcome to this revision summary video on everything you need to know about the properties of metals, non-metals and the limitations of models. Okay, let's start off with the properties of metals and non-metals then. So the properties that you need to remember for metallic bonding is they have high melting points, they conduct both electricity and heat, they are malleable, which means they can be hammered into shape, and they're ductile, which means they can be stretched into wires. They are also sonorous, which means they make a ringing sound, and they have a high density. Remember, non-metals are the opposite to that. So they don't have a high melting point, it's low. They're not malleable or ductile, they're brittle, which means they break easily. They don't conduct electricity or heat. They're not sonorous, they make a dull sound, and they have low density. Okay, let's move on to the explanation then. So why in particular do metals conduct electricity? Why do they have high melting points? And why are they malleable? As you can see here, I've got my metal atoms and they have your positive nucleus. Now when the electrons become delocalized, that positive nucleus resembles a cation. So you have a positive cation surrounded by a sea of delocalized electrons. Delocalized meaning they're free to move. This helps to explain the three major properties you need to know. Why can they conduct? Why do they have high melting points? And why are they malleable? So if we start off, why can they conduct electricity? This one's fairly obvious. They have delocalized electrons. They're free to move, so it can carry on a charge. If we move on to the melting point, there is a strong electrostatic attraction between your cation and your negative delocalized electrons. Therefore, lots of energy is needed to break the bonds. And then finally, why are they malleable? Why can they be stretched into wires? This again is to do with the strong electrostatic attraction. Now, because there is a strong electrostatic attraction between your cation and your negative electron, the layers can slide past each other. And what happens is the metallic bond doesn't get broken. So they'll stick together and can be hammered into shape. The final part of this video is to have a look at the advantages and disadvantages of molecular models. And there are 4 different ones you need to know, which are 2D models, dot and cross diagrams, 3D models, and ball and stick models. So if we start off with 2D, the advantages are they're simple. They show the atoms involved, and they also show how the atoms are connected together, as you can see the bonds here. The problem with them though is they don't show the shape, and they don't show the size of the actual molecule. If we move on to dot and cross diagrams, the great thing about these is it shows you the electron arrangement, it shows you how the substance forms, and it also shows you where the electrons are from. But it also doesn't show you the size of the molecule, and it doesn't show you where the ions are arranged when you do ionic bonding. That comes in with 3D. So you can see here I've got my ionic lattice. It shows the ion arrangement, which is really useful. As you can see, it's a regular pattern where you've got positive and negative ions surrounding each other. However, it doesn't show you the size again, and it doesn't show you the insides. You can only see the surface. And then the final model, your ball and stick model, these are probably some of the best because it shows you the shape of the molecule, it shows you the arrangement of the actual atoms, and it's more realistic because it shows you that 3D representation. However, it's misleading. The bonds and gaps aren't actually that big. They're not actually there and visible like sticks that you can see on there. So it's misleading. And also, it doesn't show you the size. And that brings this revision summary video to an end. Hi guys, thanks for watching. If you enjoyed the video, please click on like down below. You can also subscribe to my channel, you can check out the latest video, and you can visit my website up above here. Bye now.